afternoon. The next topic is stoichiometry of a chemical reaction and stoichiometry calculations. The stoichiometry means stoichiometry. The stoichiometry is the measurements of mass or volume of reactants or products involved in a chemical reaction. And for a reaction, in case of carbon plus oxygen gives carbon dioxide. This is the balanced chemical reactions representing the combustion of carbon to form carbon dioxide. From this reaction, we can say that 1 mole of carbon reacts with 1 mole of dioxygen to form 1 mole of carbon dioxide. The stoichiometric coefficient of oxygen is 1 and that of carbon is 1. The stoichiometric coefficient of carbon dioxide here is also 1. Okay. And for another reaction, the CH4, when it is burned in air, oxygen forms carbon dioxide and water. Oxygen, 2O2. Okay. And for this reaction, 1 mole of CH4 reacts with the 2 moles of oxygen, forms 1 mole of carbon dioxide and 2 moles of H2O. That is, we can say that 1 mole of CH4 reacts with the 2 moles of dioxide, forms 1 mole of carbon dioxide and 2 moles of H2O. And another thing is, from this reaction, from this chemical equation, we can say 1 molecule of methane reacts with the 2 molecules of oxygen, forms 1 molecule of carbon dioxide and 2 molecules of water. And another thing from this equation is 22.4 liters of methane. 22.4 liters of methane combines with the 2 into 22.4 liters of oxygen, forms 22.4 liters of carbon dioxide and 2 into 22.4 liters of water at STP. Okay. And another thing, the molar mass of CH4, we know it is 16 grams of CH4. Reacts with the oxygen molar mass is 32. And therefore 2 into 32 grams of oxygen forms 44 grams of carbon dioxide and 2 into 18 grams of water. Okay. From one chemical balanced chemical equation, we can say, that is, if you know the stoichiometric coefficient, here the stoichiometric coefficient of methane is 1, that of oxygen is 2, and of carbon dioxide is 1, and again the stoichiometric coefficient of water is 2. From this chemical balanced equation, we know many from about this reaction. Okay. And for the calculations, there are a number of calculations based on this stoichiometry of chemical balanced chemical equation. Let us do one problem. Calculate amount of carbon dioxide produced by the burning of 32 grams of methane. That is 32 grams of methane when burnt, how much mass of carbon dioxide is produced? That is the question. Okay. And for this, we have to write the balanced chemical equations of combustion of methane. First, you have to write the balanced chemical equation representing the burning of CH4. That is, we know the CH4, the burning means it is the reaction with oxygen, forms carbon, burned in oxygen forms carbon dioxide, hydrogen, burned in oxygen forms water. Both these elements undergoes oxidation. And for balancing, here 4 hydrogen is there, but here only 2, and put 2 here, and when put 2 here, the total number of oxygen now becomes 4 here. and therefore 2. This is the balanced chemical equation. And from this expression, these terms are in your question is in grams, and for express the quantity of reactants and products in the grams. And from this balanced chemical equation, we can say that 16 grams of CH4 combines with the 64 grams of oxygen forms 44 grams of CO2 plus 36 grams of H2. Ready? And we have to calculate the amount of CO2 produced. That is CH4 and CO2. Neglect the other quantities. And from this expression, we can say that 16 grams of CH4 produce 44 grams of. We have to calculate the carbon dioxide produced by the burning of 32 grams of CH4. And from this expression, we can say that 1 gram of, if there is 1 gram of CH4, will produce 44 by 16 grams of CO2. Ready? And therefore 32 grams of CH4 will produce the 44 by 16 into 32, isn't it? Of CO2, and it is equal to 88 grams. Ready? Okay, there are so many problems to calculate the amount of product produced by a given amount of reactant, or to calculate the amount of reactant to be used for the production of a given amount of product. For this type of reaction, you have to represent the given chemical reaction in a balanced chemical equation. Okay, it's a very simple problem. And the next is limiting reagent. If you have in place of 16 grams, 20 grams of CH4 is there. This CH4 plus 2O2 gives CO2 plus 2H2. From this expression, we have 16 grams of CH4. For 16 grams of CH4, 64 grams of oxygen needs for the completion of reaction. But if you have 20 grams of CH4 and 64 grams of O2, then 64 grams of oxygen is need for 16 grams of CH4. That is, from this 20 grams of CH4, only 16 grams of CH4 is used to react with the oxygen to produce the carbon dioxide and water. The remaining 4 grams, the 4 grams of CH4 remains as it, not affected by the oxygen. And here the oxygen, the full amount of oxygen is consumed, and this amount of oxygen determines the amount of carbon dioxide and water. Even though there are excess of CH4, that much CH4 cannot convert it into carbon dioxide and H2O. The amount of products determined by the amount of oxygen, and this is the limiting reagent of this reaction. In this case, the reactant which is completely consumed at the time of reaction is called the limiting reagent, and the limiting reagent determines the amount of product produced. If you have a പഴംപൊരി ഉണ്ടാക്കുകയാണെന്ന് ചോദിച്ചോ, പഴംപൊരി വീട്ടിൽ വൈകുന്നേരം പഴംപൊരി ഉണ്ടാക്കണം. രണ്ട് പഴമുണ്ട്, നല്ല നേന്ത്രപ്പഴം, നല്ല പഴുത്ത നേന്ത്രപ്പഴമുണ്ട്, കുറച്ച് മൈദയുണ്ട്, ഓയിലുണ്ട്, കുറച്ച് പഞ്ചസാരയുണ്ട്. അപ്പോൾ അതൊക്കെ കൂടി ചേർത്താണ് നമ്മൾ പഴംപൊരി ഉണ്ടാക്കുക. അപ്പോൾ പഴം മൈദമാവിൽ മുക്കി പൊരിച്ചെടുക്കണം. മൈദ കുറച്ചേ ഉള്ളൂ, 100 ഗ്രാം മൈദയേ ഉള്ളൂ. 4-5 പഴമുണ്ട്. പഴംപൊരിയുടെ എണ്ണം മൈദയുടെ അളവിനനുസരിച്ചല്ലേ ഉണ്ടാക്കാൻ കഴിയുള്ളൂ. Isn't it? അപ്പം that is the number of പഴംപൊരി determined by the amount of maida. Isn't it? And ഇത് ഈ കേസ് വേറെയാണെന്നുണ്ടെങ്കിൽ, that is there at that case the limiting reagent is the maida, the amount of maida. മൈദയാണ് അവിടെ ലിമിറ്റിംഗ് റിയേജന്റ്. പഴംപൊരികളുടെ എണ്ണം ഡിറ്റർമിൻ ചെയ്യുന്നത് മൈദയുടെ അളവാണ്. ഓക്കെ. ആൻഡ് മൈദ നിങ്ങളുടെ വീട്ടിൽ ഇഷ്ടം പോലെ ഉണ്ട്, പക്ഷെ പഴം 2 ഉള്ളൂ. ഇഷ്ടം പോലെ മൈദ കൊണ്ടുവച്ചതുണ്ട്, 1 കിലോയോ 2 കിലോയോ ഒക്കെ ഉണ്ട്, 2 പഴമേ ഉള്ളൂ എങ്കിൽ that case the number of പഴംപൊരി determined by the number of പഴം. Okay. And that is പഴങ്ങളുടെ എണ്ണത്തിനനുസരിച്ച് നമുക്ക് മാക്സിമം ഉണ്ടാക്കാവുന്ന പഴംപൊരിയെ ഉണ്ടാക്കാൻ പറ്റുള്ളൂ. And that case the limiting reagent is the പഴം. Okay. And that is simply a limiting reagent is the reactant which determines the amount of product or which consumed completely by a reaction. Okay. Next is the different terms used for representing the concentration of a solution. That is in your lab, your chemistry lab, you take the solutions of reactants. That is, the reactants are first made into solution and use that solution to react with each other. And at that case, we have to know the amount of the substance dissolved in this solution. That is the amount of solute present in the solution. At that case, we have to measure the concentration, concentration of the solution. And there are so many terms used for representation of this concentration. The first one is the mass percent. Mass percent. Mass percent. It is nothing but it is the mass of our solute. Mass of solute divided by the total mass of solution. Solution into 100. That is the mass percent. നിങ്ങളുടെ മാർക്കിന്റെ പെർസെന്റേജ് കണ്ടുപിടിക്കുന്നത് പോലെ തന്നെ നിങ്ങളുടെ മാർക്ക് 40-ൽ 20 ആണ്. 40-ൽ 20 ആണ് മാർക്ക് എങ്കിൽ നിങ്ങളുടെ മാർക്ക് പെർസെന്റേജ് നിങ്ങൾ എങ്ങനെ കണ്ടുപിടിക്കും? 20/40 ഗുണിക്കണം 100, 20/40 into 100, and it is equal to 50%. Isn't it? That is for the calculation of the mass percentage of a solution, the mass percentage of a solute in your solution, the mass of solute divided by the total mass of the solution into 100. That is the mass percent. And another unit, another term used for the representation of concentration is the next term used for the representation of concentration is mole fraction. Mole fraction. For a binary solution. For a binary solution means one solute present in one solvent. That is dissolved in one solvent. The solute plus solvent forms the solution. ഒരു സൊല്യൂട്ട് മാത്രം സോൾവെന്റിൽ അലിഞ്ഞതാണ് എങ്കിൽ അങ്ങനെ ഉണ്ടാകുന്ന സൊല്യൂഷനെയാണ് ബൈനറി സൊല്യൂഷൻ എന്ന് പറയുന്നത്. And for this binary solution, if the number of moles of, that is the, let A is the solute and B is the solvent to make the solution. A is the solute and B is the solvent. Let the number of moles of A is represented by A, Na, and number of moles of solvent represented by Nb. Then mole fraction of A, mole fraction of A can be written as number of moles of A divided by total number of moles, that is Na plus Nb. Like that, the number and mole fraction of B can be written as number of moles of B divided by the total number of moles, and here it is Na plus Nb. There is mole fraction is of a component. Mole fraction of a component of a solution can be written as the number of moles of that component divided by the total number of moles of the solution. For example, in case if 117 grams of NaCl dissolved in 180 grams of water. In this case, what is the mole fraction of NaCl and what is the mole fraction of water? That is uppu vellam, salt water. And in salt water, what is the mole fraction of NaCl? For the calculation of NaCl, mole fraction of NaCl, we have to calculate the number of moles of NaCl present in 117 grams of NaCl. We know 58.5 grams of NaCl is 1 mole, and therefore 117 grams of NaCl is 117 divided by 58.5 is equal to 2 moles, isn't it? And we know 18 grams of H2O, water, is 1 mole, and therefore 180 grams of water is H2O is 10 moles. Ready? And therefore total number of moles, that is, let it be NP and let it be Na. Therefore total number of moles is equal to 2 plus 10 is equal to 12. Therefore psi of NaCl, the psi is the mole fraction. The mole fraction represented by psi letter, the Greek letter psi, and it is psi of NaCl can be written as the number of moles of NaCl divided by the total number of moles is equal to 0.166. Okay, and the mole fraction of water is equal to mole fraction 10 divided by 12 is equal to 0.83. Okay. Now the next two terms are molarity and molality. R-I-T-Y, yeah, L-I-T-Y. And molarity is represented by capital M, capital letter M. The molarity of a solution means it is the number of moles of solute present in 1 liter of solution. That is, the molarity of a solution can be calculated as number of moles of solute divided by volume of solution in liters. Okay. In case of molality is represented by small letter m, and it is the number of moles of solute present in the solvent, mass of solvent in 1 kilogram. 1 kilogram of solvent. And the difference molarity is the number of moles of solute present in 1 liter of solution. And molality is number of moles of solute present in 1 kilogram of solvent. Okay, different is there. And therefore, this is two terms. Molarity, R-I-T-Y, per liter. So, molarity is per liter. Molality is per kilogram of solvent. Per liter of solution. 1 liter solution number of moles of solute that's solution molarity. And a kilogram solvent moles of solute അതാണ് അതിന്റെ മൊളാലിറ്റി ആവുക. ഓക്കെ, ദാറ്റ് ഇസ് ദ ഡിഫറൻസ്.